up on this program the Regina Science Fair, also a computerized golf game, and a personal fitness assessment at the Dr. Paul Schwann Center at the University of Regina. As well, robotics. Developments in microcomputer technology are allowing robots to do more and more things. And finally, an automated optical lab that's speeding up the time it takes to get prescription glasses. These stories on A Fine Science with Holly Preston.
Science fairs give many students an opportunity to publicly display their scientific abilities and to compete for awards. The Regina Science Fair is no exception.
It's a carnival atmosphere, but somewhere in the crowd you might find the scientists of tomorrow. Most of these students will eventually go into other fields, but for now it's all business.
Well, a tachyon is a mathematical model of a particle which travels faster than the speed of light and moves back in time. The ones that I've described here are not really true tachyons, but they're very similar in the effect that they do travel backward in time. They're extremely abstract principles in which I unify tachyons and all the different fields in nature. I can take you right through my entire computer display. First, this is a hypercube, which is a four-dimensional cube. This I use to compare alternate time systems, as my title suggests that I do. What is happening here is simply one of the effects that I have described within my boards. This is one of the most important displays in which I unify tachyons with the forces in nature. What I have shown here are the tachyons spreading out through from out of an extremely massive object, and they increase in density as we get closer to a very interesting process which I have described within my report here. I find that quite a few people just don't want to spend that amount of time, but I do get the ones that are very interested in what I'm doing. Basically, what I'm doing it now for is just for fun and to find out as much as I can. I intend to become a theoretical physicist.
Okay, what I did for my project was I was measuring solar radiation using a commercial solarimeter and comparing the results with my own homemade cadmium sulfite cell circuit. And I found in my tests, what I've displayed on the board, that the cadmium sulfite cell circuit is just as accurate as a commercial solarimeter. And the commercial solarimeter is worth $1,000, and this is worth about $15, and I made it myself. And it's just as accurate as a commercial solarimeter.
And for some, science fairs have become quite a business.
I've won several fairly major awards, including a gold medal, a trip to the London International Youth Science Fortnight in London, England, which is the international fair, and I won the Canada Award for Excellence last year, and I won a bronze medal at the last fair. This year I was working with a type of paper that has the ability to entangle mosquito larvae and kill them. And basically what it is you throw it in a pond, or in this case in small trays, with a set amount of mosquito larvae, and they can kill off a fairly good percentage of the larvae. And the chemicals I used can be commonly found in a lot of food products, including ice cream, so it poses no environmental problems. Actually, I was working with a type of seed that has the ability to lure, capture, and digest mosquito larvae, and I wanted to develop it to a stage where I could just actually treat a pond using a chemical attractant from the seed and just throw some type of device like a piece of paper in that would actually do the capturing of the mosquito larvae instead of having to grow large quantities of the seed. It's going to be a while before it's commercially applicable. It's still in the very early ages of experimentation. I think the competitive atmosphere is, I enjoy that, but you learn so much, and there's so many other experiences that a person gets out of it, that I just basically say you get a lot out of it.
And even though you may be demonstrating a principle, there's no rule that says you can't have a little fun doing it.
He's demonstrating that the applied force, which is you turning the wheel, causes the momentum, or the angular momentum, because it's on an angle. The wheel causes the angular momentum to keep you going, which makes you go in a circle, which is called precession, the act of preceding, because he's preceding around its axis. which is the rotating disc on the floor.
And having fun can spill over into the real world of science too, as we'll see in our next story. Joy Tech Limited, a Saskatoon company, specializes in an area it calls high-tech leisure. We have this story about the latest product.
Joytech's computerized golf simulator was designed for several reasons: to assist professionals in teaching, as a warm-up device before a game of golf, and just for fun, a game in itself. The screen displays are based on actual golf courses, and you can play a whole round. Peter Toner of Joytech takes us through a par 3 171-yard hole.
So the choices of clubs that the golfer has is a 1-3-5 wood, and all of the irons, 2, 3, 4, 5, 6, 7, 8, 9, and then the putter. In this case, he's chose the number 5 wood. And the shot is starting now. You can see the ball start down the fairway. We're counting the yardage that the ball travels in the box in the center. The players hit a roughly sliced shot, 120 yards. The distance to the hole is 52 yards from where his lie was. And this is the analysis of his golf swing. This is the weight distribution at setup, top of the backswing, impact, the follow-through. He's hit the ball pretty well in the sweet spot on the club. He's had the club just a little bit closed and just pushed it slightly. The club head speed was 105 kilometers per hour. So now he's got to decide which iron to hit the ball with. He's got 52 yards left to go down the fairway. So here we see the ball starting to go after his second hit. And he's just made it onto the green. He's hit the ball 46 yards and has 6 yards left to go. And this is the analysis of his golf swing again, his weight distribution. Again, he hit the ball in the sweet spot. Similar thing, he's hit it at just 3 degrees open. And he hit the ball with the club going 72 kilometers per hour. Now we have to select the club that he's going to use again, and this time we'll select the putter. And he's got the ball into the hole. We can show him, again, weight distribution. We can show him where on the club face, the ball and club impact. We can show toe to heel, where he's hit the ball from bottom to top, where the ball hit the club face. We can show where on the arc of the swing the contact was made, whether it was the ball was struck when the club was coming down or the club was on its way up. We can show whether the club face was open or closed, the approach angles, club head speed. What we have got to be able to do in order to check out the electronics is repeatedly swing a golf club with a known approach angle and a known openness or closed club face. And that's what we're using that machine for. We can then check to see what information is coming out of our sensors. We can check to see what information the computer is getting to make its calculations. And from there, what should actually be happening on the screen.
Tuning up your golf game is one thing, but getting tuned up yourself is another. A good place to start would be the Dr. Paul Schwann Center at the University of Regina.
Okay, we'll move over to the stomach now. We have a couple of methods. One is by the skin fold method. What we do during that test would be to test certain sites on the body. We test about 7 sites and do a couple girth measurements as well. And that tells us exactly how much fat is trapped underneath the skin. The reason we do a lot of sites is because one site may, in different people, one site might have a lot of fat, while another site might be lacking. Okay? Everybody gets their fat in a different spot, and there's not much they can do about it. But by taking a bunch of different sites on the body, we get an average, and that tells us how much percentage of body fat is one of the things we determine. We can tell what their ideal weight should be. We can tell what their lean body mass is, which is the amount of just muscle in their body. If we want to get a little more specific, we can also go into the underwater weighing tank. Okay? And during that test, we'd actually have the person testing their submerged weight, which will give us an idea of their specific gravity, which will tell us exactly how much fat is on the body, because as we know, fat tends to float on top of water, while a leaner person will sink heavier in the water. And that's a little more accurate way of telling exactly how much fat is on the total body.
Specialized machines, including the Cybex, are an intricate part of the assessment.
We can test 3 different components of muscular ability on that one. The 3 components is muscular strength. That would be testing at a slow speed, seeing how hard somebody could kick up and pull back with the knee. The second thing that we could test would be power, which is a more explosive thing. That's related to a sprinter trying to get out of the blocks quickly, or somebody trying to be able to do a good jump shot. Okay? The more powerful you are, the more explosive power in sport you'll have, and that's an important one to sport. The third thing is endurance, and that's just the ability to do a lot of repetitions of an exercise over and over and over.
Also included in the assessment is the aerobic test.
We can do that by a direct method or an indirect method. So we can actually hook the person up with a mouthpiece to the mouth and actually measure the MVO2 as they run up a slope on the treadmill. Or we can also do the test indirectly. Okay, so just by measuring the slope, the heart rate, the pace they're going at, we can do a prediction of that MVO2. The term aerobics actually applies to the MVO2 measurement that we were talked about. And that's the measurement of how much oxygen you're actually able to breathe in through your lungs and get into the heart, being pumped out to the muscle site. Okay, so we're looking at fuel consumption is the measurement. So what it is a measure of how much work you can actually do. We look at how much oxygen you can supply to the muscles, which gives us an idea of how much work you can capacitate. People might have exercised for 10, 15 years and think they're healthy, but when they go through an actual stress test, there are some indications that there may be problems with their heart, even though they do a lot of exercise and think they're fairly fit. Being able to do an ECG during exercise is really important to us. We can see, not only can we tell whether a person is fit or not, but we can tell things about their health. Okay, we can actually look at the heart rate to see how the ECG tells us whether the heart is getting a good blood supply or not. ECG stands for electrocardiogram, or electrical picture of the heart. That's a nice walk now. Nice, easy walk. Everybody has strong points and weak points. The fitter you get, you just tend to work on the points that are slightly weak for you. Okay, you may be above all the norms, but you can always keep improving on things.
Fitness assessment is a good example of machines working in partnership with man. But more and more machines are doing the work all by themselves. Coming up, robotics.
Thunder, thunder, thunder.
Turn me! Thundercat's Cat's Lair. Will Cat's Lair's electronic laser beam destroy the mutant vehicle?
Laser!
Direct laser hit. Cat's Lair's doors are blown open.
Get him! Fire! Retreat!
Cat's Lair defeats the mutant vehicle.
Cat's Lair, complete with mutant vehicle. Figures sold separately, assembly required. Batteries not included. It's a grand toy.
A full-flavored 100% beef patty, mustard, sauce, and pickles, tucked in a bakery fresh sesame seed bun. Dairy Queen's cooking them up right now for Canada's burger lovers. Delicious, sizzling, home-style burgers, all for an incredible price. A burger for under $1.
Whoop, but they're going fast. Oh, really fast. You better scoot on down while the burgers last, because at 99 cents, everybody's eating them up so fast, we're having a hard time keeping up the demand. But we'll try.
We treat you right.
When we travel, we look for the best holiday value. That's why you should know about Group Medical Services. Not only will your yearly premium adequately protect you when you travel outside Canada, but now it has been extended to include out of province. Plus, it offers you and your family medical and hospital services all year long right here at home. So the next time you board the plane, you'll have peace of mind knowing you are protected for the best possible price.
From Pet Food believes you should get more nutritional information and value out of the pet foods you're buying. Compare From to your present brand. No fillers or byproducts, just all natural good nutrition. Buy in the bulk size and save up to 50% on your annual pet food budget. From comes in 7 special mixes. You'll save and your dog will love it. And that's what it's all about, isn't it?
Available at these fine stores.
In recent years, great advances have been made in robotics because of new developments in microtechnology. Hugh Wood, professor of electrical engineering at the University of Saskatchewan in Saskatoon, explains.
What we're talking about is a microprocessor, and I have one in my hand. It's a chip with 40 legs on it and all covered in plastic. But inside of that chip is a tiny computer. So it does calculations. It reads a number in on one set of pins. It could read another number in on another set of pins. It could add the two numbers together and decide if that number is greater or less than, say, 15. If the number is greater than 15, it might turn off a clock or turn on an alarm, something like that. So we have the microprocessor, which is the core or the nucleus. Around the microprocessor are other chips. This one, for example, is a memory, and this memory contains the program. So what the processor is going to do, step by step. So when we build up a product, we put in the center a microprocessor, and around that microprocessor we put memory chips to store the program, other memory chips to store data that it might be collecting from the environment, and some other chips, for example, to read a keyboard or to drive a display terminal so that we can communicate with that microprocessor at the core. The robot has to have a certain amount of what we understand as intelligence. That is the ability to sense the real world, find out where objects are, and when it recognizes a particular object, to know what to do with it, and to not do something to some other object that's also in its field. It has to understand very elementary things about what to do with the object. Should it put a nut onto the bolt, or should it put some Loctite or something like that? Paint the object, perhaps. Those are the major things that robots are doing. They're doing spray painting, they're doing welding, they're doing some simple assembly tasks. But the idea is the robot is replacing, first of all, very dangerous and boring jobs. But the robot is also making possible many things that were never possible before. We have a variety of projects based on different kinds of microprocessors, all the way from very small, what we call 8-bit processors, up to larger 16 and even 32-bit microprocessors. The goal is to teach students how to design products based on microcomputers. And in addition to teaching the students, then to get some useful product design and some useful projects done for industrial organizations in Saskatoon or in the province. We teach students how to design products, how to do computer software that robots need, how to control a robot arm. That is, the robot arm has a hand, it has a wrist, much like a human wrist. It has elbows, shoulders, wrists, waists, and different parts, mainly because it's going into factory environments that are built around human beings. So most robots that we see are being built geometrically similar to human beings so that they can fit into existing manufacturing environments. But that's not at all necessary. It's quite possible that in the future we'll be designing robots that are designed specifically for different kinds of tasks and won't look humanoid at all. In fact, most robots don't really look humanoid. They're single arms. We work on advanced things like artificial vision. it's very important for the robot to get this information from the real world, that it gets sensory information just like we do. And the eye is the most valuable that humans have, most valuable organ for obtaining information from the real world. So there's lots of work here on artificial vision, that is using television cameras to take a picture of the environment, using the microcomputer to process that information and make decisions on what kind of objects are in the environment and where they are, so that the robot can go out and work with those particular objects.
The artificial vision that Professor Wood referred to is the exact technology that we'll look at in our next story.
Tradition in Regina for 21 years, the Red Ox invites you and your family for lunch or dinner, serving a fine selection of meals to satisfy your selective taste. Choose one of the many Red Ox house specialties, serving satisfaction and good taste in every meal. From salad bar to seafood delight and a children's menu, the Red Ox has private meeting rooms for birthdays, anniversaries, or any special occasion. The Red Ox, Dewdney on the Louvain, a restaurant of established quality.
Swiss Jewelers traditionally means dependability, personalized service, and a choice of quality merchandise. We're breaking with tradition and holding our first sale in 25 years. Our diamond engagement rings have been reduced by 50%. All of our gold jewelry, including chains, bracelets, and earrings, are marked down by 50%. Save 40% on all Bulova watches or 50% on Telstar watches. Our large selection of giftware has also been reduced. This is the sale worth waiting for. Swiss Jewelers on the Scar Street Mall.
Before you head to the slopes.
Before you head down the hill, head to the ski shop.
Has your old ski wear got you feeling dull? Lifeless? Then experience Detrani, the inside edge on skiing. Detrani, for the look that'll sweep them off their feet. Detrani, years of research goes into everything we make. Detrani and the Ski Shop.
Your lift ticket to excitement. The Ski Shop.
Where skiers are served by skiers.
10 years in the making. This is Quality Records' Decade of Country, starring Ricky Skaggs. 16 #1 hits. 5 times Entertainers of the Year. 6 times Vocal Group of the Year.
Closer you get.
The best of any decade, Alabama. Every track's a #1 hit. The legends and the legacy on Quality Records' Decade of Country. It's in stores now.
When you order a new pair of glasses, it sometimes takes a little while before they can be delivered. An enterprising company in Regina is working on speeding up that process.
When a prescription comes into the laboratory, a frame will be matched up with a particular pattern or former for that frame. The former is placed onto the side of the machine, and the lens is chucked into the machine. And when the edger is put into what is called its cycle, the lens is rotated against a set of diamond grinding wheels, and basically all the former serves to do is to move the head towards and away from the diamond grinding wheel. And of course the former is on line with the lens, and therefore the lens has no choice but to follow the exact motions that the former is imparting. And after 1 or 2 cycles, the shape of the former will be precisely duplicated upon the lens. There's a couple of problems. One, the actual number of formers involved. Every manufacturer of frames will supply to a laboratory a former for each style of frame, and there's thousands of styles of frames. And on top of that, there should be usually between 5 and 6 formers per style of frame, because of the different number of face sizes of the actual frame involved. In a large lab that has to deal with a whole bevy of manufacturers, one will end up looking at literally over 15,000 formers. Furthermore, the time that it takes to retrieve the formers for jobs, someone has to turn around and pull them out of the library file and put them back in, plus to catalog them and index them, is quite high. Styles of frames change quite quickly, and on the other hand, what I'm referring to there is that a new style will come in and maybe a manufacturer has not supplied the former yet. On the other hand, old styles drop out quickly, and you want to have a very quick turnover on your formers. You don't want to be stocking formers in your large library that you don't use very often. It just takes up too much space. As a result, they usually get discarded quite rapidly. And so from both sides, from old styles and from new styles, one runs into the problem of not having the former, and one has to create it or cut it mechanically. And for that, they use a former cutter.
Another problem is that the formers supplied by the companies are not technically perfect, nor are the frames. Each is slightly different.
What we ended up developing were three main components as far as an overall system were concerned. An attachment that easily attached onto existing edgers to automate them. That is, the attachment now would let the edger be electronically controlled. We can control a number of them actually from one central computer. That's the second component is a computer system that can run up to 64 at this time, up to 64 of our attachments. The most important component, however, is a very high speed and very high accuracy digital camera. And that takes the place of what would be a former cutter, which normally reads, which would normally take a frame and cut out a former therefrom. What we can now do is take a frame and with our camera scan the frame. Nothing touches it physically. And from that we create a pattern electronically, and that is stored in the computer until it is needed by a particular job, and at which point in time it goes out to our attachment and causes the edger to duplicate that pattern electronically. It essentially is a single-axis robot.
Another benefit of the new system is its capability to store thousands of patterns electronically. The patterns can be called up instantly. Overall, the process could be speeded up by as much as 75%.
The next step may be to place a camera in the dispensing office. Your new frames could be scanned, the information sent directly to the lab, and the process of getting new glasses speeded up even more. And that's our program. I'm Holly Preston for A Fine Science.
This is CBC Television.